Throughout these videos, you'll need to press pause at certain times to catch up with the notes, or if you're directed to press pause to work on a problem by yourself first and then check back in. Consider the video a personal class. When you're in class, you write what's being presented. Same concept here. Now onward and upward to what is a transformation? So a transformation is an operation, right? And remember, when we talk about operations in mathematics, we're talking about action words. So an operation that maps an original figure, the original figure is called the pre-image. So when you hear original figure, attach that to pre-image. And that maps it onto a new figure called the image. There's three things that can happen with a transformation. It could change the size of the object. It could change the position of the object, which is going to be our main focus today. It could also change the orientation of the figure. So let's start with what happens when we change position. How could we change position? Well, we'll talk about one transformation in particular. So our first type of transformation that we're going to talk about is a reflection. As you'll notice in the picture right here, we have a figure on the left and a figure on the right. And the one on the right is a mirror image of the one on the left. The one on the left is the original figure. A, B, C is a triangle. And it's reflected across this line of reflection to A prime, B prime, C prime. So on the left side is our pre-image, and on the right side is our image. And the reason I know that this is the image is these little marks right here indicate that that's the afterthought, what happened to the original picture. And I refer to them as A prime, B prime, C prime. Now I'm getting ahead of myself. Let's take a look. Well, what exactly is a reflection? It's a flip across a line of reflection. So over here, I called this the line of reflection. So what we did is we took this pre-image and we flipped it across that line over to the image. Each point and its image are the same distance from the line of reflection. So the distance for A all the way to this line is the same as the distance from A prime to this line. That's an important concept for reflections. There's a few ways that you can reflect. You can reflect across the x-axis. So you think about the x-axis. Here's the x-axis. If I were to have a point here and call it A, if I reflected across that line, I would go the same distance as I see here over to here, and then I would call this A prime. That's across the x-axis. Alternatively, I could go across the y-axis, and the y-axis goes up and down. And what I would look for is going the same distance that B is from that line of reflection across the other side to B prime. The next way we might reflect would be to go across either the vertical or horizontal lines in the form of x equals a number or y equals a number. For example, down here, I see that I have a vertical line going through x equals 3. And from algebra, you should recall that when you see x equals a number, that's a vertical line at x equaling that number. So x equals 3 is a vertical line at the value of 3. And again, I could just have a figure reflecting across that line. Reflecting across x equals, this vertical line, is very similar to reflecting across the y-axis. But instead of going across this vertical line, we've now defined one to be in a specific location. Just as we have x equals, we can also have a y equals a number. And again, recalling from algebra that y equals a number is a horizontal line at that y value. So for y equals -5, I would go 1, 2, 3, 4, 5 down, got my horizontal line, and then perhaps I had the original figure was right here, our pre-image, then I would just jump to the other side to my image. Right, so we're moving in that direction. Again, very similar to reflecting across the x-axis, but just in a more defined area. Lastly, we could go across diagonal lines of y equals x or y equals -x. So just a rough sketch. Here's our y equals x. Maybe we had a point from over here, and it's going to go the same distance to a point over here. So maybe this was A, and now this is our A prime. Let's put this into action. As we head into the examples, remember, pause the video if you need to.
Number 2, go back if there was something you missed.
3, pause when asked. We might ask you to do a question on your own.
Number 4, watch the video as many times as you need to.
And most importantly, don't be afraid to ask follow-up questions if you have any. For number 1, the instructions talk about a triangle ABC that has vertices at A, -4, 2, point B, 4, 7, and C, 5, 1. As you'll notice, I've already plotted my points. I've taken those points and labeled my triangle, triangle ABC, and now we're going to reflect this across the x-axis. So here's our x-axis. And what we want to do is we want to look at the distance A is from that axis. It's 2 units. So A prime is going to jump down here. And I've drawn the point in and labeled it A prime. Now the distance from B to this axis has 7 units away, right? That distance is a 7-unit distance away. So I'm going to go 7 units down there, and I'm going to label that B prime. My last one, C, is 1 unit away from the x-axis, so I'm going to go 1 unit away, and I'm going to label that C prime. Then I'm going to connect my points, and I have my new triangle. Now, aside from my really poor lines, I have my new triangle. Just want to draw some attention to the words pre-image. Again, that refers to the original figure, and then after the reflection, what we have, the new figure, is called the image. Now to wrap this up, all we want to do is put our final coordinates in for our image. A prime over here was a reflection of A. A was originally at -4, 2. Now it's still 4 to the left, it's just 2 down. B is still 4 to the right, but instead of 7 up, it's 7 down. And I can look at this by just counting the grid. And C, instead of 5 + 1, it jumped to 5 -1. And now our question is complete. We've drawn in our pre-image, our image, and filled in the coordinates of the image. Moving on. Take a moment to press pause and plot the points for this rectangle, PQRS. Press pause now. So like my drawing, you should have rectangle PQRS as such. And this time we're going to reflect across the y-axis, which is the vertical axis. So what's going to happen is we're going to have a mirror image rectangle sitting over here. See if you can press pause and reflect the points on your own before I do it. Alright, and as you notice, we have a mirror image across the y-axis. That distance from P to the y-axis is the same distance as P prime to the y-axis. Notice we have our pre-image P and our image P prime, our pre-image Q and our image Q prime, pre-image R prime image, pre-image S prime image. And again, just drawing attention to that distance. 7 here was, S here was 7 units away to the y-axis. Also, S prime is 7 units away from the y-axis. All we have to do now is place our coordinates of our image in the new spots here. So press pause and try that. Alright, so how'd you do? Originally, P was at 1, 2, and now P prime is at -1, 2. Q in our pre-image was at 2, 5, and now Q prime is at -2, 5. And if you take a look back at number 1, what had changed was all of the y values went to the opposite sign. And I don't want to say that they go negative because it just happened to be that all of the x values here were positive, all of the x values here are negative. That's just a coincidence. But what you'll notice is that when you go across the y-axis or reflect across the y-axis, all of your x values become the opposite sign. So if they were positive, they're now negative. If they were negative, they'd now be positive. Your y values, however, didn't change because it's just horizontal changes when you go across the y-axis. When you go across the x-axis, you're going to have vertical changes. Okay, let's move on. In this example, we're going to have a triangle, triangle JKL, with these vertices, right, plural of vertex, reflecting across the line x equals 4. And in our introduction of reflections, we said that x equals 4, or x equals a number, is a vertical line at that value. Now, I've taken the liberty to draw that line in. So what this reflection across the x equals 4 is going to be like is very similar to reflecting across the y-axis. We're going to be jumping back and forth this way. So first, press pause, draw in your x equals 4 line, draw the triangle in, and let's see where we're at. Press pause now. All right, so we have our pre-image just sitting over here on the left side of this vertical line, and if we're going to reflect, then we're going to have to jump across this line this way, and we're going to maintain that distance, that same horizontal distance to the red line. So let's just try those points. Press pause now and try to reflect across that red line. Counting boxes is the best way to fly. And by counting boxes, what I mean is K is 2 boxes away from the red line, so K prime is going to land 2 boxes away over there. See if you can mimic that for all 3 points. Again, as you'll notice, I have my pre-image and my image. L prime, J prime, K prime is a mirror image of LJK over here. And the bottom line is, this really isn't that difficult. It's just careful plotting and careful counting. Let's carefully count the coordinates of our new spot, of our new triangle rather, and let's place them over here and close out this question. As you'll notice, it wasn't as simple as just changing the sign, although our y values were originally -1, 3, and 2, -2 rather. Our x values have changed, but it wasn't just a simple change in sign. A couple more and we're home free. On this one, we're going to be reflecting across y equals 2, so you're going to have to draw a parallelogram, plot your points. Remember from the opening line that y equals 2 is a horizontal line, and that horizontal line goes through all the y values of 2. Plot those 4 points, then reflect it across this, put some proper notation, C prime, D prime, and put your new coordinates there. Take this problem all the way through. You can do it on your own. Press pause now and do your very best. Then unpause to check your answer. Okay, so how'd you do? The key piece is making sure that you count the distance to the green line when you reflect. So from F all the way to the green line, not from F to the black line. That's just the x-axis. You got to go all the way to that horizontal line. So that full distance has to be the same distance here. And this full distance here has to be the full distance there. 2 boxes, 2 boxes. The green line is the line of reflection. And then again, what happened? As we just flipped from bottom to top, what's changing are our y coordinates. Our x coordinates, -4, -2, 6, and 4, are still all there. Our last example is probably the most intimidating. Now you have this y equals x. That means that whatever the value of y is, x is. So 1, 1, 2, 2, 8, 8, -8, -8. This is our y equals x line. So what we're going to do is you're going to take a moment, press pause, and draw in your triangle XYZ. Press pause now. Okay, so hopefully you have your pre-image drawn in here, XYZ, the triangle. And now I'm just taking a look at X here, our pre-image location, this vertex right here. This is 1.5 boxes, but diagonally, right? And I'm really approaching this at a 90-degree angle. That's why I have to reflect across. It's a line drawn to the line of reflection at 90 degrees. So now I'm going to come off 1.5 boxes over here. And that is going to be my X prime. Now I just want to take a look at those coordinates. Originally, X was at -5, -2. Now, X prime is at -2, -5. So what has happened is the coordinates shifted spaces. I wonder if that keeps working. Is y going to be at 4, -3? Well, let's check. Y, I'm going to come at that green line diagonally, so 1, 2, 3.5 boxes, so 1/2 there, 1, 2, 3 right there. That's going to be my new image, y prime, and where is its actual location if we count? 1, 2, 3, 4 to the right, 1, 2, 3 down. How about that? 4, negative 3. So I guess z, its coordinates, must be at 1, negative 1, or I should say z prime. So 1, negative 1 is right here. If I may be so bold as to put it in first, and then I'm actually going to look at that reflection. One diagonal box, one diagonal box. How about that? Let's just connect our dots, and we're good to go. Now, you've gotten just about everything you need to know about reflections. There's one more version, the y equals negative x line, and we'll talk about that one in class. It's very similar to the y equals x. But you have enough to get cracking on the homework. You have a lot of examples, and the homework is what you're going to start next. Good luck, and I hope that this was helpful.